Okay, before we begin, I just want to make an announcement. Somebody asked me earlier this morning when our final is. It is the Tuesday of finals week at 8 a.m. to 11 in this classroom, C002. Now, I'm not sure if it's school policy, but if you guys have more than 2 finals on that day, come and see me. That is 2 besides mine, right? So we have 3 total finals. Come and see me, and I could probably make some special arrangement to schedule it for another day for you. We have 4 or 5 different editions of that final exam. So if you guys are one of those students that have 3, and the way you get out of this, you're not getting out of the final, but the way you get it rescheduled, if you will, for me, is you have to bring me your final exam schedule, okay? And then I'll look it over. But if you have, which I don't believe we do this, but if you have more than 3 finals on that day, talk to me and I'll try to be up here another day for you guys, okay? So it's Tuesday, I think that's May 7th, but you will have to check that out. 8 a.m. to 11 a.m. In C002. It will take all 3 hours. There's a 70 multiple choice question final, and then there's a hands-on part, okay? So you've been familiar doing the hands-on part with the exams we've taken thus far. The hands-on final will be an integrated assignment. So you'll be using Word, Excel, and Access. Any questions about that? So that's May 7th, 8 a.m. to 11. So as promised, you guys took a little poll and you wanted to decide what we're going to be doing today. And today is going to be Exam 2, Review. Now, like I said, I posted a practice exam on Blackboard for you guys to take just to hone down your knowledge and what's going to be on the exam, what's not going to be. So I will go throughout the class just asking you guys some questions here and there, just do a spot check. The exam will also have a hands-on part. The only application we're going to be focusing on is going to be Excel. The latter half of today's class, we're going to be finishing the Excel project that we started a couple weeks ago. Mainly, I want to be talking about functions and charts and formulas. Everything else seemed to be pretty good with you guys, knowing labels and values and how to format. So this exam is going to be focusing on software. I told you in the first 5 weeks when we were learning about hardware that hardware was the strength, the muscle for a computer. What would software be then if that's what hardware was? What's that? The brains. Yeah. It's knowledge. In fact, software is designed by developers or programmers, and programmers can be considered like teachers for computers. Software gives our computer purpose. It's what makes us buy these gadgets. It gives them the ability of doing something. In fact, they say computers built in the 60s, even the 50s, when they're getting into digital computing, can still run today's software. Can it run it as fast as it's being run today? No. And so we're going to get into the performance. Software comes in 2 categories. What were the 2? One is the stuff we have to have. We don't care to have it. It takes away some of the performance. The other stuff is what we enjoy to have. So 2 categories. Can somebody give me one of them? Let's see, Josh, can you give me one of the 2 types? Digging through the old notes. Take a guess. It doesn't hurt. Okay, take the word operating off, and we're just going to call it system software. An operating system is an example of some system software, but it's not the only one. In fact, it's one of the most popular examples because without an operating system, your computer's going to become worthless. But compression software, antivirus software, disk defragmenters are all examples of system software. It's not what you use to accomplish something, but it's what's required to keep things up and running. Example, in the real world, since you guys are business people, administrators would be an example of system software. They make the everyday possible. Instructors for you would be example of the other type of software, which would be what? That's what operating systems offer, but what's the other category of software? You usually get this when you're downloading these things. Yeah, apps. So basically, the way you determine the two, system software is what keeps the things running. Application is what gives your computer purpose. And as you guys mentioned, system software is really the operating system. And that's the large chunk of systems. So let's start it off. Give me some examples of modern operating systems. Windows? What version are we up to now with Windows? 8? What's Windows known for? Where does it have its popularity? Because about 90% of the market, and about 5 years ago when I was teaching this, it used to be 95. So they are losing market shares. But why do they have still the majority stake? These computers have them installed on it. More likely than not, your home computer has Windows installed on it. What is the reason that drives even us as an academic site to teach Microsoft Windows? And why do businesses use this? Because this is where the history comes in. And this is why you guys learned a bit about computer histories. What made, because remember, Microsoft Windows wasn't the very first product that Bill Gates and Paul Allen came out with, correct? Yeah, they developed the basic programming language. And when you have a programming language, what do you create? Software, right? Out of all the 4 operating systems we've learned about, what was the operating system that had the most software choices? Windows. So that's what makes Windows very attractive, is that they have a whole slew of software choices. What's the other operating system? And trust me, I've been teetering between these two. Okay, I haven't been teetering that one. Surprised somebody threw that one out there. Yeah. Let's talk about a modern operating system, one that gives us a graphical user interface. And like I said, I've been teetering between this. In fact, that's where the market shares have been going. I went out and bought one just a few years ago because I was tired of dealing with viruses. And the people I live with, I just said, look, from now on, you're going to buy all your kids this particular product because I'm tired of cleaning out their computers every week. Vanessa, what did we just say? Yeah, and so Apple's OS X, appropriately named, right? We're talking about operating systems. And the X is not really 10. It's not edition 10. In fact, when they made OS X, or OS X is what we say it, it's because it's built off of another operating system, bless you. Before we get into that operating system, though, what makes OS X unique compared to Windows? Because they both provide a graphical user interface. They both manage memory, processors, hard drives. They allow applications to be installed. In fact, these are the core functions of any operating system. So now we're talking about comparing Ford to GM. A car is a car, right? Well, some people can disagree with that. Some people buy them for status symbols. Other people buy it for fuel efficiency. Other people buy it because it's a little bit more comfortable to ride. It fits their size, if you will. So OS X, why would you get that?
I remember you saying some of them musicians like that.
I guess you could argue that the way they manage the other ones, they handle it better, so they get better performance. Possibly. Now, unfortunately, you guys cannot just go out and buy OS X and install it on your PCs. OS X will only work on Apple products. It's a proprietary operating system. Why did Apple do that? See, Microsoft, on the other hand, is all about trying to get more market shares and make more money. And so they want their products to be installed on other hardware devices. Case in point, Dell's, HP's, Compaq's, Acer's all allow you to run Microsoft Windows. But you cannot run OS X on any of those computers that I mentioned. That's what makes PCs really affordable, because there's higher competition. Apple's are expensive because only Apple makes the hardware. But what do you get when you control the hardware? Security. This is why I told my friends to buy your kids all these Apple products. What else do you get? And Apple's known for this. You're going to get better performance by way of what? Control. And that's what they're about. Because they can tell you what hardware, because they make the hardware, is going to work for your machine, and there isn't going to be this problem of when you go shopping for upgrading, is it going to be compatible? The other issue comes is when you try to install an app that says you need a high-end graphics card, Apple just doesn't allow you to do it. Windows is going to allow you to do it, but you might get poor frames per second. In other words, your movie's going to take a while and it's not going to look so smooth when you watch it. So with the proprietary, they have control, and with control, they can almost guarantee better performance, security, and it's easier to work with. That's why musicians and artist people want to work with them, because they don't want to have to go study another field when all they want to do is spend their time writing their music. Now, I said OS X was built on another operating system that's been around since the 60s. And this is why OS X is rock solid, can offer you security and better performance. Because really, Apple gave the world a way to interact with their products graphically, an easier approach. That's when the first Macintosh came out. But prior to then, Apple has changed their motto and said, look, this works for this company. Let's go over and add our usability to it. So what's the other operating system developed by AT&T and Bell Labs in the late 60s, early 70s? Unix. And hence where the X comes from. Now, when we come back from break, we're going to be going into networking. We're going to go talk about cloud computing. And as with anything in life, we always go around and around chasing our own tails and finding something that we originally came up with in the 60s to be more practical today. Unix is that operating system. Back in the 60s, early 70s, throughout the, I should say early 80s, the big computer technology that was pushing the industry was mainframes. We were just getting into personal computers, but we had these mainframes and nodes. Today, we call that cloud computing, where all we do is we access this giant computer, if you will, using our monitor, keyboard, and mouse, and that's it. All the processing and storage is held on these servers. The one operating system that's all about that is Unix. Unix is a portable operating system. And I'm talking about portability. I'm not talking about this, grabbing this and moving it over to here. I'm talking about that this operating system can be installed on many, many devices. Whether it's your smartphone, your cable box from Time Warner, your wireless router, your television, or your personal computer. In fact, that inspired a person by the name of Linus to develop an operating system that was open and free for the world to download, to modify, to fit their needs. What was the name of that operating system? Linux. So these are our 4 modern operating systems. Over here on this board, I'm going to talk about the functions that each operating system has to manage. What was number 1? Vanessa, you're right next to me. Give me one of them. There's 7 for you to pick. You want to go back to the hardware. Because remember, the operating system acts as a middle manager for you, the user, to coordinate between hardware and software. Right, folks? So, knowing this, here you are as the user. The operating system has to provide some way. And what do we call that? So Vanessa, what is that terminology used so that you can interact with the operating system? The UI. Now the user interface comes in right now two forms. There is a third one that is being implemented, and you guys are the guinea pigs. So the first one Adam mentioned, and I was actually surprised that he brought that operating system up. He mentioned DOS, but how did we interact with DOS? There was no mouse. Command line interface. Yeah, we had issue commands, and we had to type them all out. And it didn't pat you on the back when you did something right. It only yelled at you when you did something wrong. And it was very vague. You know, it's like your mom and dad grounding you, and you're like, for what? Why do you want to know for what? So you don't do it again, right? And so, likewise, command line interfaces were very hard to learn. Their learning curve was very steep because they were just like, let's get it up and running, and you'll learn through mistakes, through your experience. But it took you a while to learn because you keep on making the same mistake because you didn't realize that was a mistake, and that was what was causing the problem. So what's another way that has made us using technology a lot more friendlier and has, since this creation, made it grow very popular? Megan, you're looking at it like you got the answer. What do you think? Use your mouse. Got nice little icons, pretty pictures. I'll give you a hint, it has the word UI in it. In fact, we pronounce it as GUI, so we're just missing one letter in front of it. What's another word for image or icons? Graphical, yeah. Boy, could you imagine if you were that guy that was working for Xerox and developed the first mouse and didn't put a patent on it? Because what does Xerox make? Copiers. And they're thinking, what are we going to use a mouse for in a copier? If I had a nickel for every mouse that was sold. Now, I said there's a third one that's coming out there, and we're going to call it a natural user interface or even natural language. And I like using the word natural because whether it's touch or voice, that's how you and I interact with each other, correct? And so we're definitely moving that, as you can see with your smartphones or your tablets. It's very touch-oriented. Now, that has taken it to the next level where you can hold a button and talk to it and issue commands. And I believe they're even able to read your text messages and your emails back to you. So we're definitely moving along this natural user interface where we just treat it like we would treat each other. All right, so that's one of the many things that the operating system has to coordinate. By the way, this may how operating systems could be different too when you go to compare them. Maybe you like the Windows user interface better than the OS X's interface, or better than Linux. What else? Mariah, can you give me another one? Remember the hardware stuff for the first 5 weeks? Throw any one of those hardware terminologies out there and you're probably going to be right. Give me one of the hardware stuff out of the first 5 weeks. There you go. The processor. What is the whole purpose of the CPU? Take data in, manipulate the data into something more useful or meaningful that we call information, correct? Remember, put it in your terminology, folks. Your computer is like a business. In a business, you get raw materials. You have workers that are going to take this raw material, manipulate it, and produce a product. After all, when you're in business, you want to make money. How do you make money? By offering a good or a service. Correct? Why buy a computer? Because ultimately you care about the output. Whatever the input is, whether it's your English paper, whether it's listening or talking to a friend, it's got to be converted in a manner that can be transmitted over wires. And so when we look at the operating system, we got to ask ourselves, how does it manage the processor? There was 3 techniques. The original way was called time sharing. And in time sharing, we said, okay, I have 3 applications that are running at the same time. But they don't run technically at the same time. The operating system, see, this is the software, will pass the code or the application to the processor. But when we have multiple applications being run, the operating system will give literally milliseconds to each of those applications. Now, to you and I, a millisecond you couldn't even detect, right? But for some applications, that's a lifetime. So that's why we think when we multitask, things are happening at the same time, because they happen so fast that we assume it's the same time. It's funny. You can watch my lips move, and you can hear the sounds come out of my lips. But which one do you technically see first, or detect first? The lips moving, that is the light, or the sound coming into your ears? Which travels faster, light or sound? Light. But for all intents and purposes, since we're so close together, you can't detect the difference, correct? But when you go out there during a lightning storm, you can, right? In essence, aren't they supposed to happen at the same time? That whole influx of energy. So it gets dispelled through light and sound. And if you're there to feel it, heat as well. Hopefully you're not there to feel it. Okay? But if you're far enough away, you'll see the lightning first. And then what do they tell you to do? Count. And then you can determine the distance between you and the lightning, because sound and light have two different speeds. But since they happen so fast, just like right here, that you and I assume happens at the same time. Likewise, that's what's happening in time sharing. Our processes are so fast that our operating system's constantly filling them up, and we allocate designating milliseconds, if you will. What's the other way of doing it? Multitasking? Well, how about we go into multithreading first? And I will throw in multitasking just so we can see the difference between the two. In essence, they're one and the same, but in multi-threading, I used the example of laundry, correct? In fact, I also used that for multitasking. Remind me, folks, how often do I do laundry?
Once every 6 weeks.
It's funny how you guys can remember that, but when I ask you to remember the theory, you won't. But you won't forget this. So we look at it and we say, okay, every 6 weeks, why do I build up that amount of clothing? Because if I were to do it the way you were doing it with time sharing, assuming that you only have one washing machine and one dryer, right? I only could do a load at a time, and it would take me a lot longer. So I'm applying this computer theory and making my life a little bit more efficient. Let's talk about multi-threading in this. The task of doing laundry requires 3 things: organizing, washing, drying, and folding. Right? Now, the first thing you probably could do if you had enough hampers on the fly. That is, when you get done taking your clothes off, put the darks in one hamper, the whites in the other, or the colds in the other, you know. The point is that we break the application into tiny threads. That's what each of these would be. And then we try to organize our time that if we have enough data that needs to be processed while we're doing one task. So we start here. I'll put C for clothes. And then the next step, the clothes are getting in the wash. While they're getting washed, the next set is getting organized, correct? But I can't do anything with the dryer. Why can't I do anything with the dryer? Because I haven't had the first wash through yet. So then, while I'm at this, I'm busy while they're busy. Now I'm getting the full swing. So by step 4, I can't do this just yet, right? Because I'm in the middle of folding now, correct? So do you see how certain threads can be ran simultaneously? In this one, I'm doing 3 things at once. Up here I was doing 3 things at once, but up here I'm only doing 2, and there I'm only doing 1. And that's where multi-threading comes in. The operating system looks at an application, sees the different subtasks that the application can be conducting, and then tries to manage it accordingly. All right. How do we take this to the next level? And this is why I do my laundry every 6. By the way, I'm up to doing laundry this break week. Where am I going to this weekend? Laundromat. And I'm going to probably go on Easter because nobody's there on Easter. But what do I gain by going to a laundromat? A lot of dryers. And that's where our processor with multiple cores come in. Because now I could be washing multiple loads at the same time. And that's why our operating system needs to understand what our processor can do. Because if you have a multiple core processor, they can say one application is being ran on this side and the other is being ran on that side. Okay? So that's how we manage the processor. What's the other thing? And this becomes very apparent because, folks, as I'm doing my laundry, I need some workspace. What is that workspace when it comes to a computer? Memory. And remember, I said that the CPU and memory are so close together, they have a really tight relationship that physically, they're also close together. Because if we could, we would try to load the whole program on the CPU. But why can't we? Because the CPU only has so much space, so much waiting room. When we were learning about processes, we called that the cache, correct? That's like the buffer area. And we are trying to add more and more cache to our CPUs. In fact, as you compare last year's models to this year's models, you will see we're up from 8 megabytes to 12 megabytes, which is a complete joke compared to RAM. Today's computers will come with 8 gigabytes of RAM. Just to show you the difference between the mega and the giga, that's like you getting a pay bump between $1 one year and $100,000 the next year. It's that huge of a gap. It's that big of a difference that even with the more memory we have, it's really trivial to look at our cache size. We want more cache, but we can't get that because our processors are pretty small. So we add more memory. And what happens when we run out of memory? Which is becoming a dying process right now. We have to borrow from the hard drive. When we borrow from the hard drive, we get what we call virtual memory, right? What's the big issue about borrowing from the hard drive? And this is why we are adding a lot of memory to today's computers. Because the hard drive is the weakest link, correct? We get the worst performance. And if we are using applications and not closing out of them, we're going to run out of workspace. By running out of workspace, it's like doing this. If that cotton's coming in from the fields and you're making a t-shirt, you ran out of workspace for your employees in the warehouse, guess where you're sending your new employees at? In the back of the truck. Where the cotton's being held. That doesn't make sense. They can do some work there, but are they going to be as efficient as if they were in the warehouse working? And if they had all the appropriate tools? No. So virtual memory, we want to try to get rid of it, or even the concept of doing that by increasing the amount of memory. If you can't afford to increase the amount of memory, or you don't have enough physical slots to do this, the only thing I can suggest is close out of applications you are no longer using. And folks, the devices where we cannot increase memory and that we are suffering dramatically from are your smartphones and your tablets. They only have about 64 megabytes of memory. Maybe we're getting up to the gigs, but remember, these are small devices. They can only hold so many transistors. So, if you're finding that your phone is dying a lot quicker than it usually is, close out of the applications that aren't being ran because they're in memory. What have we learned about memory when electricity goes out? You lose it, right? So if an application is being stored in memory on your smartphone, the smartphone needs electricity to keep that application in memory, correct? So if you're not using the application but it's in memory, what does that mean about your battery life? Training. Close out of the applications you don't use it. Not only will it increase your performance, but it will also increase your energy or your battery life. What's the other thing that the operating systems, by the way, that's all those. Any modern day operating system has to handle these things. Morgan, what do you think? Give me another thing that I haven't mentioned here. How about we call it file management? The only reason is because the hard drive isn't the only device on your computer that can store files. Your flash drives, your optical drives. So yeah, file management. Big exercise we did in the first week of class. The ability to create files and folders and to organize them, delete them. Mitch, I haven't heard from you for a while. Give me another one. Well, let me throw it out. What's that? We got that right up in here. Think about how we use networking. Yes, absolutely. You just took the words right out of my mouth. Josh, did you guys decide to go with that Chromebook or not? All right. Yeah, $50 more and you get a full-blown computer, right? When I was talking about networking and operating systems, I threw a thing out there that Google's trying to push. It's called their Chromebook. And it's like $200 if I remember correctly or something. Is that what you found, Josh? Okay, so the Chromebook, which one was, what was the price for that? Oh, really? Okay, so they're still Chromebooks. Great. So they're in the $200 range. And basically what you're paying for is the monitor, keyboard, and mouse, if you will. They're laptops. And it doesn't come with an operating system like you're used to. It's more of like a web OS. And in order to get to it and use these books, you have to have a network connection. And they don't tell you that. But does it matter about storage and all these other things? Well, you're out of that control because the operating system's on a server somewhere around the world. The huge benefit about this is that all your applications and files can be accessed anywhere, and you don't have to worry about upgrading the computer because it's stored on a server that has huge processing power and memory and storage. The only thing that really depends on is this right here, your connection to the internet. And the faster our internet becomes and the more affordable it gets, folks, the way of Google Chrome is going to happen on every operating system. Instead of logging into these computers, you guys will come and you might even have a touchpad, a tablet, or just a monitor, keyboard, and mouse, and that's it. So our operating systems now have to start accepting that they're not alone anymore like we used to be in the 80s. That we are connected together to share resources. Whether it's these resources or these resources, today we also have to manage our networks. And mark my words, the next version of Windows 8 or Windows or whatever operating system, there will be better control of your network throttling capabilities. Because in a house right now of 7 people that I'm staying at, we have a nice connection. Nice for 1 or 2 people. But for 7 people, it can be crazy. So we have to shape the traffic. And that required for me to buy a separate device. No different than back in the early 90s or the late 90s, I had to buy a firewall to protect the traffic coming and going. But in Windows XP and beyond, doesn't that come automatically now? And that's how an operating system handles these features. And they forever grow. Another feature that an operating system will handle under networking is bandwidth. How much priority you get. So when mom and dad's up there, they're not waiting for you guys to get done doing your Facebook. They can pay their bills and not have to wait for that little hourglass to keep on churning. All right. How about I/O devices? What are ways for your operating system to handle that? What is an I/O device? Can you guys give me an example of one? Dan? Yep. So Dan's saying your flash drive, maybe. Flash drives are tricky. They're really getting cool because they're starting to do more than just be storage devices. But as you're suggesting, they plug in through USB, and hence the mouse, the keyboard, the printer, the monitor, basically the devices that you guys interact with to get data in and information to come out. So how does the operating system handle that? If I go out and buy these, I'm all waiting for Christmas this year. They got these goofy looking glasses. And I'm not talking about Google glasses. I'm talking about something even more goofy than that. That when you wear them, they have a little motion detector on there. So when you turn your head to the left, the screens that make up the glasses will move the character to the left. So when you guys are playing your video games, no longer do you have to use your thumbs to control the camera, if you will. You can use your head. And what's neat about this product is that it's actually, for the first time ever, accepted by all applications and video games. There is no, in order for this to work, you have to buy this. And it only works with these games. Because the developer said, you know what? This is an I/O device. The screens are the outputs, right? Your head becomes the mouse, if you will. So when they plugged it in through the USB, it became a composite device. So the computer now recognizes your head movements as like a keystroke, and then the glasses to be screens. And it's pretty fascinating because all I have to do is install this one special piece of software that comes with the hardware that tells the operating system how to use it. What is that device? What is that piece of technology called? Device driver, yeah. Now, most of the time, you guys aren't using the device driver that comes with your hardware because we have this new technology called what? Plug and play. And you just simply plug it in there and it works. Hence the name plug and play. All right, did I cover them all? I said there's 7. What am I missing? All right. Which we will save until after we come back from break because we have a whole lecture on security and ethics and using today's digital technology. These are the functions that those operating systems up there have to handle. There's no exception to the rule. If that you're going to play in today's modern world, you have to have this. Okay, so how do we create software? Brittany, I haven't heard from you for a while. See, doesn't it suck when your instructor knows your name? I don't have to run up here to look at the attendance sheet and be like, so, what do you think, Brittany? How do we develop applications? We're using a program called Small Basic, right? And Small Basic represents a programming language. Okay, and we watched a video, and in that video they said something along the lines that programmers are going to be the new rock stars. Adam tried this with his wife, and she didn't buy it. So he was trying to justify his geekness. But sorry, Adam, but eventually she will recognize that you're going to be a superstar. She hasn't already done so. I mean, she did marry you, right? So, any case, why did they feel that they wanted to push this onto the next generation and make programming language a second language, just like Spanish or German or French? Why do we feel like programming should be an important skill to have?
It's a way to talk to the computers and language to manipulate.
Think about the whole world around us and how we use technology for everything that we do, but yet we don't speak its language. You right now are functioning at a level as I did when I went over to Europe to visit my brother. I got to see some things, and I got to have a good time, but I didn't have a great time, and I didn't have the most of what I could have been when I was there as if I was here. What do I mean by that? Well, when I was landing in Germany, I couldn't read any of the signs, so I spent hours trying to find my way. Hours! That time could have been spent sightseeing. But because I didn't know the language, I wasted my time thumbing my way along. What else? I couldn't communicate with the people, and if I can't communicate with the people, how do I grow? How do I enjoy the area? How do I learn about its culture, its history? Likewise, when I was showing you guys Excel, we were just using it on the very surface of it, and I said there were some features that it was lacking. Remember we were creating that portfolio? And the feature that it was lacking is that I had to go out to the web and grab the ticker results every day to update my portfolio. Now, to me, I thought that's something a monkey could do. And I said, if a monkey can do it, I can teach a piece of equipment to do it. And that's what programmers are. They're teaching electricity to communicate with us, to do something practical. Now, that's one side of the argument. Now, I'm a big advocate because programming teaches you to think. Now, the only way I got through college was that we got into study groups. And I ended up being a teacher in every one of the study groups. And they're like, that's what you should do. You should drop out of computer science and go into education and start teaching at elementary. And I started laughing and go, they don't pay very well. Lo and behold, I ended up being a teacher anyway. And as a programmer, I think we make excellent teachers, and I think teachers make excellent programmers. Why? And why do I say that if you really want to learn this material, you should become a teacher? Not a paid professional teacher, but maybe a teacher in a study group. You must know your stuff for you to be able to teach it, correct? And the only way you get to know it is when you're sitting in front of a class or standing in front of a class of 15 people expecting you to be this fountain of knowledge. But more importantly, a teacher is one that can relay the information in a manner that you guys can understand it. Programmers have to constantly train their thoughts, translate it into a way computers can understand that. That's what makes an excellent manager. Because you guys are business people, and you're gunning for managerial positions, not teaching positions, and not entry-level factory workers. So you need to understand the process. Every company has a process. I don't know what it's going to be for where you work, but I do know this. It's going to be your job to bring new, I was going to say faculty, but staff or employees on board. And part of your job is to get them up to speed so they can work well with the others. And that will require you to create some kind of process, which we call in programming an algorithm, a set of steps for them to follow. And HR, what do you guys call that? Policies or protocols, correct? So that's it for about programming, other than when we go to create an application, applications run on what? It's when we take the CPU and we add the operating system to it. So what's the other word? What's the word that I'm looking for that begins with a P? That it's the CPU plus the operating system. And this is what software runs on. And the whole slew of it's changing with iOS devices, smart devices like Android, Apple's, Windows Mobile now. What do we call this? What do you guys call something that you stand on top of? Lifts you up. Platform. Now, last night when I was getting ready to prepare this lecture, I came across something. We've talked about web technology, talked about HTML5 and how I was so excited about it that one of the games that I used to play when I was in high school is going to be all web friendly. I know it doesn't sound much to you guys, but if you own an iPhone or an iPad and you access a particular website and the iPad says to you, sorry, it uses Flash. What does that mean to you as a user? You're limited, right? But the whole idea of the web is to have this cross-platform nature. That is, no matter what operating system or what hardware you're using, you should be able to access it, correct? Well, video games are notorious for this counter philosophy. You can only play certain games on certain platforms, whether it's the Xbox, the PlayStation, or so on and so forth. Just like you can only play Blu-ray movies on Blu-ray players. So when we implement something to the web, we want to make it cross-platform or platform independent. Except when it's Flash. And so when HTML is coming out, HTML5, they're getting rid of Flash. And it's pretty exciting to see from a programmer's perspective that we're taking something like a video game and making it into an interactive web page. Now, I'm not asking you guys to appreciate that or even to understand it, but what I'm trying to tell you is that video game I used to play on my Nintendo 64 now can play on my iPhone, my iPad, on any device, even my Blu-ray player at home, because it all handles the web. And that's all you need, right? In fact, what type of software must we have to be able to go browse on the web? Flip those two words around and you have it. A web browser. So, when we design code or applications, we need to be considerate of the platform, and so we have two ways of compiling the software. We can compile it so it runs to a particular platform, and hence the word compiler, or we can use something called VMs. Virtual machines, remember we explored that a little bit? Where we emulate the hardware that the application would run on. And the case in point when it comes to web technology is Java. You can write code one way, one time. And by using an interpreter like Java's VM, that code will run on any device that can handle Java. And that's what makes the web such a pleasant place. And this is my transition coming from software down to the web, because the web in itself is starting to become the modern day operating system replacement. And that's what Google's trying to push to you guys. You have things called web apps. You have real-time communications. You have, I wouldn't say unreal communications, but asynchronous communications. That is, you could talk to this person by sending them an email, and then they can respond when it's their convenience. So what's the difference between like web apps and traditional apps? Getting into this real-time collaboration thing. What makes web apps so... By the way, I would consider Facebook a web app. And all you need is a web browser, correct? And an internet connection. They're free?
They store
for now.
They store information.
All right, so you have possibly access to a large selection of data. Yeah, but I'm looking for something more than that. The relationship. That these apps are like little islands, if you will. And the only way they get resources is whether you're shuttling it between apps. Here, when we do Google Docs, when you guys come back, when I set you up for a group project, we're going to only have one document. And in that document, everybody's going to be able to contribute to it. Whether it's the same time or asynchronous. Now, my friend, the one I've been telling you about, people I live with, she teaches at Mansfield University, and she's been giving a group project. And the students are just complaining left and right. You guys do a good job at that. You make us better teachers by doing that, by the way. And she's like, oh, next semester I got to do this differently. Because the biggest complaint is it's an online class. How do you get together in an online class doing a group project? And so I showed my friend Google Docs. And she's like, that's what I need to do next semester. Because the students can get in there. They can see each other using webcams. They can edit documents, the same document, simultaneously. So they're not passing around multiple editions of files. All their work is stored in one place, so they can't say, oh, I sent an email to so-and-so to send me their work. No, it's right there. Everybody has access to it. So the ability to share and collaborate in a real-time environment is what makes these apps sexier than those apps. And we're starting to see a transition between those two. In order for that to happen, what are the web technologies that Sir Tim Berners-Lee developed back in the 90s? Remember, I drove a point to you guys that the internet and the World Wide Web are two different things. They go hand in hand, but still they're two different things. It's like buying a burger from Burger King's at the mall versus buying it right down here in Corning. The mall offers a convenient location, correct? Because there's a bunch of other stores within that facility. Whereas if you buy it downtown, you always have to go through all these traffic lights to get there. And mainly when you go get gas, isn't that one of the determining factors? Do I make a left across this intersection, or do I just make this right here? So the web in itself is something like that. The web is the mall. It's a technology that allows all these other things that you're used to accessing via the internet more user-friendly. In fact, we said that the web is more of a graphical user interface for the network, for the internet. So what makes that possible? Give me some technologies that make the web possible. HTML, which is the markup language. And that's one of the things Tim Berners-Lee made. It's called Hypertext markup language. It's very simple. It's not even a programming language. And he had to keep it that way. And the reason why he had to keep it that way is because the people that he was dealing with weren't programmers. So he had to make it nice and simple. What else? The protocol that allows us to transfer web technology. Hypertext transfer protocol. Remember, protocols are a set of rules that tell people how to conduct their business, if you will. What's the last thing that he developed that you and I are quite fond of? Because I hear your mouse clicking all the time. Links. Hyperlinks. Now, I like to take the word links and replace it with the word URLs. What does the URL mean? What are the U, Adam? What does the U mean in URLs? Wendy, what does the R mean? Very generic. I've been throwing this out. Instead of calling it files, I called it resources. Very generic. Because remember, the internet is comprised of a bunch of things. Whether it's video, music, web pages, even apps. We're just calling them resources. Jessica. The L. Close. Locator. So let me give you an example of a URL. What's the first part? What's that P in HTTP? Protocol. Folks, save those brain cells. Spend them on something else. If you know what the P stands for and you see this in a URL, then just assume that this is the protocol part. This is going to become important because the web is growing, and right now we are associating web traffic as HTTP. We might have a video protocol later. And so the web will become like your TV. You sit back on a lazy boy and you use a remote to change it. What's this part? Now, if you were to go to myccc.corning-cc, you're going to get a different page, a web page, than if you were to go to this part. Because remember, this whole thing is considered the domain. But this is like a subpart of that. And they both offer two different types of, begins with an S. And think about it. When you come up on campus, there's these different departments, like SAS. So what does the S stand for in SAS? Or the other S, the last S, not the first S. First S stands for student, right? Services. And that's what this is. These are the services that that particular domain can offer. You can find out if you go to mail.yahoo, email is a service, correct? It isn't the only service offered that, it isn't the only service that a domain can offer or a company can offer. So what do you think the www is going to be? What do those three W's stand for? So is this going to be the public side of the company, right? And here, when you guys go to this site, don't they ask you to log in? So what's this part right here? Technically, it's this larger part, but I've been saying it. It's the service that the blank can offer. Domain. Can anybody get a domain name? Yeah. Depending on this, what is this called? I'll give you the letters. Whoops, if I can get them right. TLD. The D is short for domain. When you think about domain names, you got to think of a hierarchy. They're going to be organized. I told you that they're finally releasing the XXX domain, right? And I told you that the porn industry is very disappointed in this. Why are they disappointed in that? Because I'm telling you, our IT people are loving it. Yeah, you do not go to this site, whitehouse.com. And if you do, do it on your own time. Because if you wanted to visit the White House's webpage, it should be whitehouse.gov. These are a top-level domain, and they allowed us to categorize basically web pages or websites. So can you guys get a .edu? No, unless you're an institution, and it has to be a higher level institution, higher learning institution. Could you guys get a .org? If you have that special tax form that proves to the government that you are tax exempt and you run a non-profit organization. Can you guys get a .gov? .mil. That's short for military, right? .com. .net. How about dot followed by your last name? We are now growing and we're realizing that our domains they're too narrow. So now we're expanding them and offering you variations. Like you can go to YouTube by typing in youtu.be. Makes it a shorter URL, right? Easy to put on business cards. But think about it. Wouldn't it make it cute? You can go to .cc or something like that instead of the dash. So they call it abbreviations, if you will. All right, that's the theory stuff. Minus on your exam, and this is just a general overlay. You can see I spent a lot of time on OS stuff and the stuff that the operating system has to be responsible for, and software. I do talk about web technology. In a nutshell, basically this. The other theory stuff that's going to be on the exam is going to be covering your office theory. Like maybe what a cell is, what a record is, what a field is. Things that I've talked to you guys in person, we went over the office applications. What I want to do now is just cover a little bit of Excel. Hopefully you guys downloaded the Excel spreadsheet. By the way, do you guys have any questions on this? Seems like you guys have the general idea. You need to brush up a little bit, polish off the rust. And we're live, and there we go. So if you guys downloaded that spreadsheet, you should be greeted with this on your screen. Remember, Excel calls it a workbook. A workbook is comprised of worksheets, correct? The things that go across the top are called what? This is a softball pitch. What do you guys call these things that have letters? Oh, generically in a spreadsheet. Column. What do you call these numbers? And what do you call the intersection of a column and a row? Cells. How do we reference cells? There are two ways. Well, technically three if you count the mix, but... Well, you click on them to get the address in the formula, but what do we call the two different cell references? One's relative, and the other's absolute, right? And in a minute, you'll see the difference between the two. And a cell is always addressed with a column first, followed by a row. You good about that? So, for instance, I need everybody to click on cell C2. It says the initial amount invested. There's more than one way of doing this. I'm going to take the shortcut. What cell could I use to reference this amount? Look at what's been given to you. I'm looking about how much money I invested into my portfolio. E12. So E12. Let's click on E12 and let's see how they were able to calculate that. By the way, that's what makes Excel really attractive, is the fact that you shouldn't have to whip out a calculator to do anything, right? And it looks like they are using a special function called subtotal. Is that what you guys have in your formula bar? Would the sum function work here? Absolutely. Just another function. Let's go back up to C12. Now my question is, how do I reference that cell? Because that's where the answer is stored. With an equal, exactly right. Folks, Excel, equal, they both begin with an E, but more importantly, Excel is a glorified calculator. In algebra, we're constantly working with equations, correct? So anytime you're typing in a formula, make sure you have that equal symbol there to begin with. Equal what? Adam, since you're the one started out? So just click on E12. Hit enter. Do you notice it gave it a little different exotic cell reference because this is a table? But did it take the answer and put it right up here too? Now, naturally, it might not make sense to do this within a worksheet, but you might have another worksheet called a summary, and then that's what you do it there. All right, what are we going to do here? Current portfolio value. So we got to hit equal. What are we going to click on next? G12. Let's do that. Hit enter. Now we want to know if we made money or not. I like percentages, not actual dollar amounts. Percentages are scalable. And if I had more money put in there, it would scale appropriately, correct? I mean, if I made $1, if I contributed $1 million, I'm not going to brag to my friends I made $1 when I put $1 million in, correct? So, how do we do this? In order to show this growth or this percentage change, I'm going to take my initial amounts, right? Subtract current value and divide the initial amount again. I know it sounds funny, but let me write it up on the board so you guys can see it. The reason why I'm going to remove my initial amount from there is because, C3, I can't count the money that I've put in there of myself to see if it grew. So for instance, if you guys put $1,000 in a bank account and at the end of the year they say you have $1,100 in that bank account, you can't say you made $1,100 that year. You only made $100, correct? Because you got to take the amount that you made out. So it's going to be what the total is at the end minus what you put in to begin with. Why am I putting these parentheses in? What have we learned in math class? Please excuse my dear Aunt Sally. What does that mean? Order of operations, right? Because I want this subtraction to occur first before the division. Hence the please is parentheses. So let's do that. Equals. Now you guys can type it in accordingly or you can click on each of those cells. And did you guys get 25%? That's a nice return on investment. Over in the G column, we have high and low. What do we mean by that? I only threw this in here because I wanted to illustrate how to use functions in Excel. So it's sort of just like a moot point. But high, what are you thinking? Your highest earner, maybe? So let's click on H2. First of all, we're going to be calculating the highest earner. So out of these different, well, in database, what do we call them? Fields, right? So out of these different areas or categories or fields, which one should I be using? Let's go through this. Should I use the purchase price? Nah, that doesn't make any sense. How about the number of shares? By the way, we're going to fix this. I'm not really happy about that. Purchase cost? Current price? Current value? I think to me that might be a winner. Could I also do loss and gains? Yeah, I like loss and gains, right? Why do I like loss and gains? Because you know what? Even though this one looks like it cost me more, maybe it didn't make me as much as the other ones, correct? So let's do that. But the question is, how do I do that? Do I just type in 1146 and hit enter? Why is that not a good idea? Why is it not a good idea to use hard-coded values like there, like 1146? Yeah, I mean, that's what happens with stock prices, right? They're constantly changing all the time. They're usually going down, as you can see. But in any case, we need our spreadsheet to be flexible and accommodating. Hence, we need to use formulas, cell references, or functions, okay? So I'm going to delete that H2. By the way, what do we call this black border around the current cell that you're in? Active cell pointer. Okay? So make sure your active cell pointer is in H2. And how do I launch the functions dialog box? You're getting into formulas. You do need an equals, you do, but I'm going to make it even easier for you. Yeah, if you're a calculus person, we have this little thing called f of x, which is just shorthand for function. That's it. You have that right up here. In the formula bar to the left of it. Do you see why I'm throwing this terminology out there for you guys? Because I can say to the left of the formula bar is the function button. Click on that. Now I've been blessed. They had the two functions I was looking for right up here. Do they have the min-max functions for you guys? You might have that, you might not. So Excel gives you the ability to search. The nice thing about their search is you don't have to know the name of the function to get it. You can type in like high or greatest value, and eventually they'll return a function that deals with the max. If you do not have the max in this box up here, just type in max, and it should appear for you. So type in max, hit enter, and it should display the max function. Did it do that for you guys? All right, so is it highlighted in blue? Good. Click OK. Now, it took a guess. It said from C2 to G2. But didn't we talk about from H to here, right? So it was a poor guess. How do I fix that? Hit the backspace key on your keyboard. Since this text is highlighted in black, that should delete everything in number 1. And you guys have this little icon over here. Click on that. And what that'll do is it'll sort of collapse the dialog box, allowing you to see your worksheet. Click and hold from H7 down to H11. When you get done doing that, you should have a marquee for this region. Hit enter. Notice it does something a little bit goofy, and it says table 1 gain / should say loss there. Why do I like doing this? If you guys weren't working with tables, you would see the cell addresses H7 to H11. But why did I prefer making this a table versus working with a generic spreadsheet? What happens when I add more stocks to my portfolio? This is going to be updated now. See, if I use the cell address from H7 to H11, if I add another row between H11 and H12, that new row will become 12, but guess what's going to happen? It's going to be excluded from that range. Does that make sense? That's why I like using tables. Very flexible, a little hard to work with. By the way, did they come up with the same results that we did? 1146, is that the right one? How can I format that so a comma appears right there? So leave that highlighted, come up here into the number group, and click on the comma. Now you have those 2 decimal places. Folks, when you're dealing with thousands of dollars, are you going to worry about a penny? In fact, when you guys do your taxes, it's coming right up, right? But what does the government allow you to do? It's very generous of them. They allow you to lop off those 2 decimal places, right? Unless it's 99 cents. No, I'm kidding. All right, so how do we get rid of those 2 decimal places? Come up here in the number group and click on the arrows pointing to the right. All right, you guys try to figure out how to do the low. And I'm up here if you have questions. So do the same thing we did for the high, but do it for the low. By the way, now's also your time to ask questions like when you did a lab and you went back to look over the lab and you're like, I'm wondering why I got that wrong or this wrong. Tell me. I mean, this is why I'm here. I can address those issues for you guys. So the way I'm going to do this is I'm first going to hit enter. And it's going to drop me down to H3. And I'm going to click on my f of x button. Fortunately, the min function is here. I knew to use min because the opposite of high is low, so the opposite of max must be min. But if I didn't, I'd type in low up there. I'm going to click OK. Once again, it took a guess. It guessed above me. Poor guess. So let me close out of that. Or sorry, delete that. Click on this box. Select this region between H7 and H11. Hit enter. And I get negative 478. That is the lowest, correct? Let's click OK. And for me to quickly format that to there, I could use the format painter, but it's just as quick to come up here and hit that a couple of times. Why am I getting parentheses and not the negative symbol? Yeah, we're using an accountant format, and when you see that, it just means negative. What color would you guys prefer if that was negative? Red. And what do we call that when we format something based off of a condition? Conditional formatting. Yeah. All right, last thing to do. Some of us are visual learners. If you only had 5 seconds to look at this and come up with an answer, this is not friendly for a 5-second overview. What could we use to give us a visual aid to represent the same stuff, and so that when we look at that visual aid in 5 seconds, I have an answer? A graph. And you're preferring a pie chart. Why did you say a pie chart, not a bar chart, line chart, or any of the others? Or a scattered graph? Because you're hungry and you like pie? Okay, that works. Translation. Pi is used to represent comparison within a common subject, if you will. In other words, you are comparing these to each other, correct? And isn't that what our goal is? What is our best performing share or stock? So a pie chart's the best one because it's a comparison tool, and it's only focusing on one topic, that is the stocks. When you are focusing on two quantitative measurements, you might want to go a line graph because that is an X and Y axis. So typically in business, you guys are dealing with time and maybe cost. So cost is usually up on the vertical or the Y axis, and time's across the X axis. All right? Sales might be an example of it. How are your quarterly sales looking like? And you might group them, what? Fall, spring, summer, winter. Okay. So first thing I need to do is I need to highlight from A7 to A11. Why am I selecting that region first? What does that region represent? We call them labels, right? Now, it would have been nice if the values that I want that represents each of these labels were right next door, but they're not. And the reason why I said they would have been nice is because I can click and hold and drag there, right? But they're not next door. It doesn't make sense to use the dates as the values for comparison. So how do I select this region here and let's do something different. Let's do this region right here. So how do I select this region here and this region here? That's what I wanted to hear. Good. So hold the control key and then come over here and click from G7 to H11 and let go of the control key. That allows you to select non-adjacent cells. I love that because that makes the job easier. Let's click on, well, you guys tell me, where do I find the pie chart? All right, what do you think you're going to click on now? All right, but click on the arrow next to pi, and let's get a little fancy, and let's pick the 3D pie right here. Just this first 3D pie. Now remember, when you're creating a pie chart or any kind of chart, your idea is to relay complex information in a very simple an easy format so that anybody can understand it in 5 seconds, correct? I want to move this to another worksheet so it's bigger and it's easy for me to add titles, labels, and markers. So how can I move this to another worksheet? Don't tell me copy and paste or even cut and paste. Vanessa, you want to say something? There it is. So with this selected, you got a whole new bunch of tabs up top. All right, under the Design tab, you should have this command called Move Chart. Let's put a dot next to New Sheet. And let's just leave it right now as Chart 1 and click OK. And what that should do is make it a nice 8.5 by 11 sheet of paper with that chart taking up the whole thing. Now, I'm going to show you something that makes this rather unique. Click on one of these slices, just any one of them. Notice when you click on them, every slice is now selected. How do you know they're selected? They have these little object dots. Okay, let's click on that purple again. Notice when you click again, only this slice is active. I'm not a big fan of purple. We're going to change that color. And the way we're going to do that, we're going to go up to the Home tab. You see I have that paint bucket? This is the one that's making me money, right? What color should I make it? Yeah, there you guys go. I'm going to come on that paint bucket, click on that, and click on the green item right here. But you know I'm having a problem because that green is too much like this green. So why don't you guys change that color? I don't care. You can make that one purple. But you know what also would be nice? That I can take that slice and rip it away from the rest of the pie. This is called exploding the chart. So I'm going to click once on that slice. It's active. Only that slice is active. Then I'm going to click and hold on that slice and drag it away from the pie. And now I have an exploded pie chart. And the last thing, or sorry, two things I also want to do is I want to add percent labels to this. And I also want to add a chart table, or sorry, title. Can anybody tell me how we're going to add labels to this? Go back to the chart tools, maybe click on design. I think I want to click on layout, but another way of doing that is right clicking on it. So I'm going to click on layout, and then you guys see where it says data labels? Click on that. And let's put it right in the center. But what was the issue? Did it only add it for that slice? Why did it only add for that slice? That was the only one that was active. So hit the curvy funny button up top in the left corner, the undo button. How do I select them all again? First you have to deselect. So click anywhere in the white. Did those little handles go away? Now click on the pie chart again. Now does every slice have their handles? Very good. Go back up to the data labels and click back on center. Now I wanted percentages. What did they give me instead? They gave me the dollar value. Well, did you notice when you went up to data labels, there was an option down here that said more data labels? Let's click on that. This time, remove the check next to value and put it in percentage. Now click close. And now you guys have percents. Last thing, add a chart title. Under the layout tab, you guys should have a command called chart title. Please click above. Now, it's active. If it's active, you can start typing. When you start typing, you're not going to see it. I'm going to type in current stock values and hit enter. When I hit enter, the chart title should now appear. Of course, anything on a chart can be selected and can be changed. If I wanted to make my percentages bigger, I can click on any one of the percents, go back to the Home tab, click the font size button, and let me quickly demonstrate that for you guys. Home. As I click on that, I'm getting it. I can make it bold. The idea is, if you can click it, you can change it. If you don't like having the legend over there, you can click on that and hit the delete key, and that'll take the legend off.